All right, so the in-class practice problem, this is actually a problem in the book as well, but the book phrases it strangely. It's problem number 62 in the book, but I rewrote it so that it makes a little bit more sense, I think. So what we have in this problem is a hydraulic system that has an input cylinder and an output cylinder. And you want to assume that the output force is 100 times bigger than the input force. And based on that information, what is the ratio of the area of the output cylinder to the input cylinder? That's a whole lot of words. So we have an output cylinder and an input cylinder. This is a hydraulic system. So what does this look like? We should draw a picture. Hydraulic systems, basically you have one side that's smaller connected to another side that's bigger. And then you fill this up with a fluid that's called incompressible. That means the fluid doesn't change the size that it has. You can't compress it. So I make this an airtight seal inside of here. So if this is airtight, if I push down on the left-hand side, if I push down there, what's going to happen on the right-hand side? This is going to go up. Because I'm going to push down, that's going to be pushing down on this piece of fluid right here, which is going to push on the fluid that's below that, fluid below that, all the way on, and it's going to translate that force out to the output cylinder. This is the way that my brakes work. I actually have hydraulic disc brakes on my bike. There's fluid inside of there. When I push on the brake handle, that pushes all the way down so that it clamps my brakes and stops my bike so that I don't run into cars that randomly stop right in front of me. Okay, so that is hydraulics. And the key equation for hydraulics has to do with pressure. Pressure at one position is equal to pressure at all other positions. And we usually think about this as an input pressure and an output pressure. So P. Capital P. Why don't we use lowercase p? What is lowercase p? Momentum, obviously. Okay, so P for pressure. P1 equals P2. And pressure is basically just taking a force and applying it over an area. Some force, apply it over an area. So the force divided by the area. One point is the force divided by the area at another point. And this is the key for kind of all of these problems. All of these problems are going to use this equation in some form. I can have different ways that I can talk about force. So a force could be a mass that I place on top of something. And gravity is the thing that's doing the work. So that might be mg. Maybe that's the force that I'm using. Maybe I'm applying a push force, something like this. Any of these will work. Area is going to be the area of your shape. Usually we're talking about cylinders. What's the area of a cylinder? Pi r squared. We got excited about that question. Oh. Okay, pi r squared. So that's typically what the area you'll have. That's the shape. Okay. Any questions on this hydraulic thing? Hydraulics or pressure? We've all been getting shots lately, probably. Vaccines and flu shots and all that stuff. Have you ever noticed different shots, different sizes of needles? Anybody ever gotten shots with different sized needles? Which shots hurt the most? Big needle or little needle? Big needle or little needle?
Big needle looks scary.
Big needle looks scary, but which one do you feel more? Big needle or little needle? Have you ever gotten a shot and you haven't felt it at all? Yeah. I've had good doctors that do that, right? My vaccines, I haven't felt them because the needles are really small. That's because of physics. You have to have some certain amount of pressure to break the skin, right? If I have a small needle, my area is small. If I have a small area, then it's a small force to get out the pressure. Versus if I have a big needle, that's a big area. If I have a bigger area, I need a bigger force to make the pressure to break my skin. So big shots hurt worse. Get those small needles, tiny needles. So when you're developing drugs and developing vaccines in your little biology labs, make sure that they're tiny and go through tiny needles. So then it won't hurt my arm when you give me shots. Okay. How many of you want to go to med school? Raise your hands. Okay, so you're the ones that are going to be giving me shots. Okay. Make sure, small needles. Okay, so for this particular problem, we're not talking about needles. That's what druggies use. We're talking about cars or big forces. Assume the output force is 100 times bigger than the input force. So let's say we have pressure out has to be equal to pressure in. So I'll put it in the form of what we talk about in this. A hydraulic system has an input cylinder and an output cylinder. Assume the output force is 100 times bigger than the input force. So F out is equal to 100 times F in. Given this information, what is the ratio of the area of the output cylinder to the input cylinder? So I really don't have lots of numbers here. I've just given lots of equations, lots of things to find. So I know pressure out is pressure in. Pressure out is made up of the force that's out over the area that's out is equal to the force that's in over the area that's in. For those that want to go to med school, this is the type of question they would ask on an MCAT, because on an MCAT, can you use a calculator? No. This is the question that they can ask you that you don't need a calculator to answer. Okay, so F out over A out equals F in over A in. Now we are asked to find what is the ratio of the area of the output cylinder to the input cylinder. When we talk about ratios, the first thing is the numerator, second thing is the denominator. So area out over area in. That's what I want to find. A out over A in. How do I get that? Do I have all those variables in my equation? I have A out, I have A in. So how do I get that? I have to do algebra. I have to manipulate this. What should I do?
F out is 100.
F out is 100 times F in, so I can plug that in. 100 F in over A out equals F in over A in. Okay, what can I do now? Anything? F in cancels out. I can get rid of F in. No more fins. Don't like seafood. Okay, so now I have 1 over A in. What was that? Multiply times A out? Is there a reason to do that, or are we just trying shit? I think there's a reason to do that. So multiply both sides by A out. My A out cancels on the left-hand side, and I'm left with 100. And that's equal to, now I have A out over A in. That's what I'm looking for. A out over A in equals 100. Done. All algebra. Just an algebra problem. Just reorganizing this algebraically to give me A out over A in, and that's all. Plugging in what I'm given. That is more or less how you'll do most of these pressure problems. Questions on this? No? I do recommend working on the in-class problem, problem number 60. It has a couple more steps than this. It's a little harder in some ways, but then a little bit easier because they give you numbers.